So I'm going to go ahead and write an example. You'll just have to leave a blank for the pages that you missed, and then you can come back and pick them up. So the first one is going to be 2x plus 3 times 3x squared plus 2x minus 5. And I told you that the only thing we're going to do today is we're going to use the matrix. Much easier method when you've got big numbers and big things that we're working with here. So what I want you to notice is I have 2 terms and I have 3 terms. And so what I'm going to do is draw my box. And I always keep the lowest number of terms on the left, and then my largest number of terms is going to be across the top. So I'm going to split it here, and then I'm going to split this into 3 boxes. So on the left, I'm going to take my first 2 terms, 2x plus 3. And then across the top, I'm going to go ahead and just copy these down. 3x squared plus 2x minus 5. It's real important that you keep your signs on those. Okay, and then we're just going to basically fill in the blanks. So I'm going to do this one first. So we multiply our coefficients. 2 times 3 is 6. Keep the base. And how many x's do we have? 3. Okay, so this is 6x cubed. I'm going to work my way across, and then I'm going to come down and do the second row. So now, what is 2x times 2x? 4x squared. Okay, 2x times negative 5? Negative 10x. Okay, we're going to come down to here. 3x squared times positive 3? 9x squared. 2x times 3? 6x. And negative 5 times 3? Negative 15. Now, if you notice, because of the way we set up our problem, we can combine these 2 terms, and we can combine these 2 terms. And that's the nice thing about setting it up like this. So the 6x cubed doesn't have anything that can be combined with, so it's just going to come down as part of our answer. Okay, so what is 9x squared plus 4x squared?
13x squared.
Okay, so plus 13x squared. So the exponent doesn't change on that. We're just adding up how many we have. 6x minus 10x, negative 4x. And the negative 15 comes down, and that's our answer. Okay, so kind of get the idea? So you can see that these boxes definitely help. This matrix helps keep everything organized on these problems. So here's example 2. 2x squared minus 1 times negative x squared plus 3x plus 2. So once again, we have a 2 by 3, so that's what we're going to draw when we do our matrix. We'll plug in our values. So on the left, we have 2x squared and negative 1. And then across the top, we'll put all 3 of those terms. Negative x squared plus 3x plus 2. Okay, see if you can fill in your boxes. All right, so what did you get for your first term here?
Negative 2x squared.
Good. Okay, our next term?
6x cubed.
Everybody good? Everybody okay? Okay, 2 times 2x squared?
4x squared.
Negative 1 times negative x squared?
X squared.
Positive. So all we're going to do now is change the sign of all of these. So this is going to become negative 3x, negative 2. Everybody okay there? All right, and then when I look, now I'm going to do some circling this time. It didn't quite work out so that I could circle across this way, But what can actually be combined here?
4x cubed and x cubed.
Whoa, careful.
Sorry.
4x squared and x squared. So I'm just going to circle them independently in there. I know those two can be combined. Anything else that will combine together? No. So we're going to end up with a lot of terms in our answer. So I'm just going to bring stuff down. Negative 2x to the 4th power plus 6x cubed. Now remember that I want to try to keep them in order of my exponents. What is this one going to give me when we combine? Okay, plus 5x squared minus 3x minus 2. Just a big answer, but still a pretty easy problem. Hey, everybody okay to there? So that's a binomial times a trinomial. This last one that I'm going to give you is a trinomial times a trinomial. So example 3, whoops, I always do that. When I try to write example 3, I write my E backwards. Example 3.
I just did that too.
Mentally, it's like I'm jumping ahead. Okay, so here we go. 2x squared minus 4x plus 5 times 5x squared minus 3x plus 2. So what should our matrix look like on this problem? 3 by 3, right? So we're just going to draw it a little bigger. That's all you have to do on this one. And it really, on this one, doesn't matter which one goes down the left and which one across the top. I typically write the first one down the left and then the second one across the top, but it really doesn't matter. So, and the nice thing about the matrix, you guys, is it works no matter how many terms that you have in your polynomial. This will work the same way every single time.
So did you have to do this by FOIL?
Yeah, we would have done this. We would have just distributed one term at a time, so we didn't know how to do this at the time. I did when I went to college. I took a class called linear algebra, and at that point we did these matrices, but we didn't do it in high school. So that was,
How do people find those like equations?
how did they find, like the little tricks like the matrix? I guess just messing with it and figuring it out. So, I don't know. Okay, see if you can fill in your blanks here.
I don't know if it's right though.
Because we could test it against the other method. You know, I could use the other. Oh, that wasn't very nice. I could actually distribute it, and I could compare answers and figure out that it works. So that was not very nice. We can actually just combine like that. So I'm going to bring down my 10x to the 4th power. Okay, what is this going to give me? Negative 20 and negative 6 is negative 26x cubed. Now, this way, I'm just going to do 2 at a time. So 25 plus 12 is 37 plus 4, 41x squared. Okay, negative 15 and negative 8. Plus 10. And that's the answer. Okay, does anybody have questions?